While multiplication and division of complex numbers can be done through patterns in polar form, how do we add or subtract complex numbers in polar form? This is answered here in Mathematics of Engineering. The polar form of a complex number is configured as the modulus r, CIS, the argument theta. This is interpreted as the modulus r times cosine of theta plus I times sine of theta. In adding and subtracting complex numbers in their polar form, it is required to convert the complex numbers in their rectangular forms. Add or subtract them accordingly. Then place the result back into its polar form. In case we are to add twice of cosine 67 plus I sine of 67 degrees to 7 times cosine 45 plus I sine of 45 degrees, then subtract 3 times cosine of 115 degrees plus I sine of 115 degrees, the first thing to do is to convert all three complex numbers into their Cartesian forms. From the first complex number, the real number is solved by multiplying 7 with cosine of 45 degrees, giving 7 root of 2 over 2. 7 times I sine of 45 degrees also gives 7 root of 2 over 2 times I. From the second complex number, the real number is solved from twice of cosine 67 degrees, giving 0.7815. Its imaginary number is twice of I sine of 67 degrees, which results to 1.8410I. From the third complex number, we get the real number as 3 times cosine of 115 degrees, which is negative 1.2679. And its imaginary part is computed from 3 times I sine of 115 degrees, which becomes 2.7189 I. Now let's deal with the operations. The second complex number is added, but the third is subtracted, so we change signs. Negative 1.2679 becomes positive, and 2.7189 I becomes negative. Then we are ready to collect similar terms. Starting from the real numbers, we take 7 root of 2 over 2 plus 0.7815 plus positive 1.2679, giving 4.4633. The imaginary number is taken from 7 root of 2 over 2 plus 1.8410 minus 2.7189, resulting to 4.078I. If we graph these coordinates, we place 4.4633 along the real axis and 4.078 along the imaginary axis. So the vector we get is from the first quadrant. Now let's revert the result back into its polar form. So take the modulus using Pythagorean theorem, and that is the root of the squares of 4.4633 and 4.078, resulting to 6.0458. The argument is solved using the inverse tangent of 4.078 over 4.4633, which gives 42.4171 degrees. This value of theta is exactly the measurement of our graph. Thus, we can finally say that z is 6.0458 times cosine of 42.4171 degrees plus I times sine of the same angle. To shorten it, we can write z as 6.0458 CIS 42.4171 degrees. The second example uses radians. Z is the root of 2 cosine of half of pi plus I sine of half of pi minus twice of cosine of 3/8 of pi plus I sine of 3 pi over 8 less half of cosine 5 pi over 6 plus I sine of 5/6 of pi. Convert all three complex numbers into their Cartesian forms. The first has a real number as root of 2 times cosine of half of pi, giving 0. Its imaginary number is computed as root of 2 times I sine of half of pi, giving root of 2 times I. From the second complex number, compute the real number as 2 times cosine of 3 pi over 8, giving 0.7654. Its imaginary part is twice of I times sine of 3 pi over 8, which becomes positive 1.8478I. The third has a real number taken from half of cosine of 5 pi over 6, which is negative root of 3 over 4. Its imaginary part is half of I times sine of 5 pi over 6, which is a quarter of pi. Clarify the signs. The second complex number is subtracted, which flips the signs into both negatives. The third complex number is also minus. So we flip the signs again before adding them. For the real part, add 0 with negative 0.7654 plus positive root of 3 over 4 and get negative 0.3324. From root of 2, subtract 1.8478 and 1/4 to get negative 0.6836I. Take time to graph the coordinates. With negative 0.3324 on the real axis and negative 0.6836 on the imaginary axis to have a vector in the third quadrant. Next is to revert the result into its polar form. Take r as root of the squares of negative 0.3324 and negative 0.6836 to get positive 0.7601. The argument is the inverse tangent of negative 0.6836 over negative 0.3324 to get 1.12 radians. If drawn on the Cartesian plane, theta is in the first quadrant. So the vector is aligned but in the opposite direction. So add half a revolution pi to get the proper argument of 4.26 radians. Thus, z is 0.7601 times cosine of 4.26 plus I with sine of 4.26. In short, 0.7601 CIS 4.26. Be careful when the problem involves both degrees and radians, like the next example. Again, convert the complex numbers into their Cartesian forms. The first one has 2 root of 2 times cosine of 3 pi over 5, giving negative 0.8740 for its real number, and 2 root of 2 times I sine of 3 pi over 5, which equals to 2.69I for its imaginary number. Take note that they are computed with the calculator in radians mode. The second complex number has the real part as 3/5 of cosine 85, which is 0.0523. Its imaginary part is 3/5 of I sine of 85 degrees, giving 0.5977I. The second complex number is to be subtracted, so flip the signs of both its real and imaginary parts. Focusing on the real numbers, negative 0.8740 minus 0.0523 is negative 0.9263. The imaginary part is then 2.69 minus 0.5977, giving positive 2.0923i. Illustrate this to identify the vector. From the Cartesian plane, mark negative 0.9263 on the real axis and positive 2.0923 along the imaginary axis. Thus, it is observed that the vector is in the second quadrant. Next is to convert the Cartesian form into its polar counterpart. The modulus is then the root of the squares of negative 0.9263 and 2.0923 to get 2.2882. Next is the argument from the inverse tangent of 2.0923 over negative 0.9263. The result is negative 66.12 degrees when we use mode degrees. Graphing this argument will show a vector in the fourth quadrant, opposite to what we have at hand. So add half a revolution, 180 degrees, to coincide with the resulting vector, and get 113.88 degrees. In case we are to use radians, convert 113.88 degrees by multiplying pi over 180 degrees to get 949 over 1500 pi. Therefore, Z is 2.2882 cosine of 113.88 plus sine with I of 113.88 in degrees, or 2.2882 cosine of 949 pi upon 1500 plus I sine of the same angle in radians.